7. This is apply the fundamental theorem of algebra. Okay? So, what is the fundamental theorem of algebra?
The degree is how many solutions.
Okay. The degree of the polynomial, okay, is how many solutions that you have. Everybody agree with that? It is not Santa. Stop. It's not Santa, so stop. It's It's not Santa. Santa has a beard. Okay? So who was the guy that discovered Freddy Goss? That's what he looks like. Yeah, that's Freddy. He's just got a little beanie. Come on, he's cool. Of course he's cool. He's a math geek. Okay? All right. So, Freddy Goss discovered the fundamental theorem of algebra, which says the degree of the polynomial, which is the highest exponent, right, is how many solutions it's going to have. Okay? So, let's look at one of them. F of x is equal to x to the third plus 2x minus 11. Alright? So let's just pretend that we're taking the 50-point test. Alright? Because I like practicing. Why do I like to practice? It makes you better. Okay? The more you practice, the what? The better you get. Okay? So don't yell it out loud and don't show me your fingers. But write down in your blank how many solutions this polynomial has.
Okay, quick question. Whenever it says number of solutions, it's the number of possible solutions, right?
Yeah.
No.
No. Get out of here.
You're out. It's the number of solutions. It has that many solutions.
Yes. Yes.
If there was possible solutions, if that was many of them, yeah, like some of them can be non-real.
Seesaw.
Yes.
All right. How many solutions does this have? 3. Okay? Okay, we're recording, so don't be silly, all right? I'm all up for silly most of the time.
What I meant was number of solutions including non-real solutions.
Yeah, imaginary solutions are still solutions.
Okay, that's because some of the problems I've had, like I worked for 45 minutes on one, and like I got
Some of them were
I
imaginary.
got 2 solutions in like 5 minutes. I was like, how do you get it? And then I looked in the back, and it was 17. And looked in the back, it's like, oh yeah, you already have all the answers. The rest is just non-real.
That's right. Okay, so now you have 1 minute to do this. Tell me the possible rational roots. Yeah, you really need 30 seconds.
Why'd you give us a minute?
I know. I don't know, because I got confused. Because y'all are distracting me.
Done.
Okay, everybody got it? What y'all write in the blank? Plus or minus 1 and 11. Okay, so this is what we did yesterday. We said that it's plus or minus P over Q. And it's like heaven. We equated it with heaven, right? Where the last will be first and the first will be last. So the last number, the constant, goes on top, and the leading coefficient goes on the bottom. And then we listed the factors of this. Do I care about the negative 11? Because we're doing plus or minus, right? So it doesn't matter what it is. All right, so the factors of 11 are 1 and 11, and the factors of 1 are 1. And then you have to put, if there were 2 on the bottom, like this number in front were 3, then I would have to put 1 and 3, and then I'd have to put 1 and 11 over 1, and 1 and 11 over 3. Do you understand? Everybody okay with that? No? I got somebody that was absent, so I'm going to change this. I'm going to change your problem. It's not going to affect what we're doing. All right, let's put a 3 right there. Now tell me the possible rational roots. Okay? Yeah. I just changed the whole problem. All right, so everybody got them? Okay, so the factors of 11 are 1 and 11, and the factors of 3 are 1 and 3. And then we're just very methodical, right? We take all these numbers on top and we put them over 1. I did that. All right? And then we take all the numbers on top and you put them over 3. So that's 1/3 and 11/3. So now I have how many possible rational roots? 8, because of the what? The plus or minus. Okay? So now we're going to talk about a new guy. I think it's only one E. This is Rene. Rene who? Rene Descartes. That's exactly right. Because guess what? He was a Frenchman. Okay? So, he was a French mathematician. Okay? Yeah, Rene is a guy's name. It is. In France it is. Just like Francis is a guy's name, right? Francis is a guy's name. Mostly that's Italian. Okay? But what do they call him? Frank. Please, don't you watch Blue Bloods? What's the matter with y'all? His name is Francis.
Very occasionally, and only because it comes on after 5 and because it's
okay. And his dad sometimes calls him Francis, all right? But they call it, all his friends and everything call him Frank. But anyway, all right, so Rene Descartes, a French mathematician, okay? Look, this is what he discovered. It even got named after him. It's called Descartes' Rule of Signs. Descartes' Rule of Signs.
He only made one rule?
Do you know what he said? He said, hey guys, don't put Descartes before the horse. That was good. Fun. That's good. That's okay. It's an old saying, don't put the cart before the horse.
Oh, I thought you said the horse before the cart. I get it. I thought you said before
Thank you, Jada.
I thought you said divorce.
No, I didn't say divorce. Okay.
I looked at Cart more than you. We're breaking up.
Okay, Descartes' Rule of Signs. Here's what Descartes' Rule of Signs says. It says, the number of sign changes in f of x is equal to the number of positive roots. Or lesser by an even number. I'll talk about that. It's kind of a little afterthought, but I'll talk about it. Okay? Guess what else he discovered? The number of sign changes in f of negative x is equal to the number of what? There you go. The number of negative roots. Or lesser by an even number.
What do you mean by that?
We're going to talk about that. Okay? We're going to talk about it. Now, before I explain this little rule to you, Descartes' Rule of Signs, I want to tell you, remember how I told you yesterday I was going to teach you another tool to put in your toolbox, right? So we got a lot of tools in our toolbox. Do we need every tool for everything? No. Okay? I mean, if I'm going to change out my window pane because someone broke one of my window panes, okay, then I'm going to go to my toolbox and I got to get the caulking out, right? So I can pull the window pane out and then go up there to the glass place have them cut me another one and put it back in. So, am I going to point my hammer to get the caulking out? No, I'm going to get a screwdriver or a scraper or something like that where I can dig that caulking out. Okay? So, does that mean I don't want a hammer in my toolbox because I'm not going to use it? No. You're going to need it sometime. Okay? So, here's what I'm going to tell you about this tool. Sometimes this tool is very useful and it tells me a lot. Sometimes it's kind of useful, and then sometimes it's not useful at all. Alright? But the point is, you have to learn it. It's going to be on your 50-point test and your big test. Okay? Because sometimes it does tell me a lot. So we're going to use this problem and we're going to do it. Now, here's what the chart looks like. Because there are 3 types of roots. What are they? What can a root be? It could be what kind of a number? A positive, a negative, or imaginary. Okay? Now these 2 rules only tell you how to find positives and negatives, right? Okay, so what about these imaginaries? Well, let's talk about them for a second. Could I have 3 imaginary roots? Yes or no?
Yeah.
You can?
Yeah, there's no limit to what you can do.
There's no limit to what I can do?
I don't know.
Okay, let's think about how do you get an imaginary root? What has to happen? You have a negative under the radical. Okay? What's right in front of that radical? What kind of, a plus or minus? So now let me ask you a question. Can you ever have 3 imaginary? Why? That's exactly right. They come in pairs, guys, because of that plus or minus. One, you could have a 1 plus 3i, and the other one would be 1 minus 3i. They come in conjugate pairs. That's what we call them. Okay? So, these imaginary numbers, that's where this comes from. Lesser by an even number. So, they're coming in groups of 2s, like the arc. Okay? 2 by 2 they come. Alright? So, what are we going to do with this number? You're going to get this number right here, and then you're going to subtract 2 from it until you can't take 2 anymore. Okay? I'm going to look over here, and what am I going to count in f of x? The number of sign changes. Okay? So let's look at this. What's this? Positive or negative? Positive. So a positive to a positive. Does that have any sign changes? No. A positive to a negative. Does that have any sign changes? So there's 1 sign change. Now what did I tell you to do to it? Subtract 2 until you can't subtract 2 anymore. Can you take 2 from 1? Then you can't do it. That's it. Okay? Alright. Now we're going to find out the number of negatives. So all I need to do is find f of negative x. Now, did we do this yesterday? Oh, yeah, that's that same skill we did yesterday with the negative 1. Who is the only thing that's going to change signs? The who? The odd exponent. So if it has an odd exponent, it's going to change its sign. So do I change this sign? So he becomes a negative 3x to the 3rd. Now this is an x to the 1st. Do I change his sign? Yes. So he becomes minus 2x. Can you ever change the sign of a constant? People, it's a constant. That's why they call it that. Okay, because it's constantly negative 11. It's not ever going to change. So minus 11. Now I'm going to count the sign changes. How many sign changes? 0.
Wait, so that means there's 2i. Okay, wait, no. So what we do is I'm completely lost right now.
All we did was find f of negative x.
Oh,
Okay?
okay.
And then we changed his sign because he's an odd exponent, and his sign because he's an odd exponent. You can't change his. And I counted. Now listen to me. Let me make sure you understand this. Am I counting the sign changes from this polynomial to this polynomial? That's not what this says. It says the number of sign changes in f of negative x. It didn't say how many sign changes from f of x to f of negative x. Don't get hung up on that, okay? I'm just going to look at this and say, how many sign changes are there? Zero. There's none. They're all negative, okay? Obviously, you can't take 2 from 0, so this is it. Now, why is that useful in this problem?
Because we just found out that out of all those numbers, only one is in that solution that we can find.
And it has to be what? Positive. Did I just knock out 4 of the 8 possibilities? People, am I going to try f of negative 1?
No.
You can, but it don't work. They just said there are no negative roots. Okay? You see how nice that is? So this one worked out really nice. Now let me tell you about the eyes. The eyes are what we call fillers. That means I just use them. How many do I have to get? 3.
And that's being
Yeah, that's it, y'all. There is a total of 3 roots. Okay? So 1 and 0 make 1. So how many do I lack? 2. So this one, there's not any other possibilities. There is going to be 1 positive root and 2 imaginary roots. Okay? Not many of them work out that way. All right? Not many of them just have 1 possibility. Most of them have more than 1 possibility. All right, so everybody understand how to do it. Okay, so let's go over again how to do it. First, you're going to look at the polynomial, and you're going to count the sign changes. That tells you how many positives there are. And then what are you going to do with that number? You're going to write it here, and then subtract 2 until you can't subtract 2 anymore. Y'all, that means if this number right here is 7, then you're going to go 7 and 5 and 3 and 1. I either have 7 positives, 5 positives, 3 positives, or 1 positive. Does that help me very much? That's not very helpful. You see what I'm saying? Sometimes it'll be helpful, and sometimes it won't.
I get what you meant by that. So it's like you either always have 0 positives or 1 positive, and then you spend it 7, write that down, then 5 and 3 and 1.
Okay? All right. So then you're going to find f of negative x. And then you're going to put that number right here. And then what are you going to do with that number? Subtract 2 until you can't subtract 2 anymore. Okay? And then we'll talk about what to do. All right? Okay, so here we go. Are y'all ready for a good one? It's a good one. I love this problem. F of x is equal to x to the 6th minus 2x to the 5th plus 3x to the 4th minus 10x to the 3rd minus 6x squared minus 8x minus 8. Okay, I'm going to keep pretending, guys. I'm going to keep pretending because we're going to keep practicing. The more we practice, the what? The better we're going to get. So, go over here and write number of solutions. Put you a little blank, and then write your number in the blank. What'd you write in the blank?
6.
Perfect. Possible rational roots. Is that the problem I want? Yeah, I think so. All right, what are your possible rational roots?
Plus or minus 4 and 8.
Perfect. All right, everybody okay so far? Okay, so let's do Descartes' rule of signs. Oh, sorry, I don't know what happened to me. I'm just going to lead you, okay? I'm going to lead you. So, I want you to fill out the plus column, okay? You should be able to fill out the plus column. We talked about it. We did it. We talked about it. All right, everybody got that one? Okay? So you had to go up here and count the sign changes. The first sign is what? So positive to negative. There's 1. Negative to positive. Positive to negative. To negative. To negative. To negative. So there's 3. Or 1. Okay? Does everybody understand that? Okay, so now I want you to find, just do this first. Find f of negative x. You do that first. All right, that's what you should have gotten. Now, fill out the negative column. You're doing the same thing we did on this one, guys, except you're looking at this equation. Okay, when you counted the sign changes, how many did you get? 3. Very good. So, there's 1, there's 2, and there's 3. 3 sign changes. So there are 3 negatives or 1. Very good. Now, here's where the kids got messed up. Okay? I did them all in the same color. It's the reason I'm doing them in different colors. Because I did them in the same color, and the kids thought I pulled these numbers over into these columns. Y'all, can you pull these numbers over into this column? You can't. These are the number of negative roots. These are the number of positive roots. Okay? So this is the way I'm going to say it. This is the boys, and these are the girls. Can I put girls in the boys column? Can I put boys in the girls column? Okay, but we're going to the dance. And every boy has to dance with every girl. Okay? Every boy has to dance with every girl. So here's the deal. 3 has danced with 3, but 3 has not what? So you have to write 3 and 1. Okay? Now, has everybody danced with everybody? No, you haven't. 1 has only danced with the yellow one.
Okay.
Who does 1 also has to dance with? The yellow 3. You have to get all the combinations.
That would have been better. And the eyes equal up to 6.
And the eyes have to make the total be 6. So, 3 and 3 make 6. How many do I lack? Okay, are you getting it? 1 and 1 make 2. How many do I lack? 3 and 1 make 4. How many do I lack? 1 and 3 make 4. How many do I lack? So here's my part. There it is.
How is it valuable?
Is this one very valuable to you? Here's the only way I would say this were valuable. If I found 2 positives, then what do I know?
It's not the 1.
So there has to be what?
either 4.
There has to be another positive. Very good, Alexis. She said, y'all, if it's either 1 or 3, and I found 2, it must be the 3. Okay? You see what I'm saying? So it's either, well, it's either 3, 3, and 0, or that'd be 3, 1, and 4. Okay? I would have knocked out this one and this one. All right? So is it?
Yeah.
Oh, I don't know. 3, 1, and 2. Sorry. I just went down and then went across like an idiot. All right. So it's either 3, 3, and 0 or 3, 1, and 2. That would be if I found 2 positive ones. All right? Now look, am I going to put a problem like this on this 50-point test?
No.
Because why? Yeah, you don't have enough time. You don't have a calculator. Okay? You're just flat out guessing it. Okay? That's all you're doing. So, that's not what I'm looking for.
Well, there's only 1, 2, 4, and 8.
It is. You're right. It's not lots of possibilities. Okay? But I'm still not going to. That's not what that's about. All right. So, Ron, you just say, take it and say thank you. And go on about your business. Okay. Uh-oh. What's this one saying?
It's going to be long. You don't understand the first? I understand it now. I didn't understand it first, but I understand it.
I'm not writing the equation. I'm just telling you I counted the f of x's. It had 9 sign changes. I found f of negative x. I counted it. It had 4 sign changes.
Not too bad.
It must have been a 13th degree equation. So fill the chart out. You're going to like it.
I like it. I keep writing X.
I did that while ago too, Spencer.
I'm going to get confused on the who dance with the who.
It's just mashing, really. To me, that's what I say. Huh?
Do we have to finish filling this out, or do we have to write the equation for it?
No, you don't. You're just filling it out.
Because she didn't tell us. She said she
I just made this up.
Get out of here. Whatever happened to this?
What? Okay, are you ready? Okay. Not now. Okay, so 9. There's either 9 positives or there are very good. There are 4 negatives and now it's just a question of matching everybody with everybody. This 9 has to be matched with 4, 2, and 0. He's already matched with 4, so what do I lack? So I'll go 9, 2, and 9, 0. Okay?
Can I ask you a question?
Yeah.
Is it legal if, like, once we establish how many negatives there are, if we went 999, 777, 555?
However you want to do it,
Okay.
as long as everybody's matched with everybody. Okay, 7. 7's already matched with 2, so who do I need to match him with? 4 and 0. 5 is already matched with 0, so who has he not been matched with? 5, 4, and 5, 2. 3, he's not matched with anybody. Who do you want to match him with right here? 4, and so now who does he lack? 3, 2, and 3, 0. Okay? 1's not matched with anybody right here, so you just want to start at the top and go 1 and 4, and then it'd be 1 and 2, and 1 and 0.
That's
Sorry.
0.
Now what do I want to do?
Add them all up.
Yeah, now you got to look. Look, it has to go across and make 13. So 9 and 4 is 13. I don't need any. 7 and 2 is 9, and I need 4. Now, anytime I add these, and then I need something like 3 here, what do I know? Either you don't know how to add, or you don't know how to subtract something. You see what I'm saying? There's a mistake. Because the numbers in the I column can only be what kind of numbers? Even numbers. Because imaginary numbers come in conjugate pairs. So 5 and 0 make 5, and I lack, what, 7? 8? Sorry. 3 and 4 make 7, and I lack 6. 1 and 4 make 5, and I lack 8, Tommy said. 9 and 2 make 11, and that makes 9 and 0 make 9, so I lack 4. 7 and 4 make 11, I lack 2. 7 and 0 make 7, I lack, thank you. 5 and 4 make 9, I lack. 5 and 2 make 7, and I lack. 3 and 2 make 5, and I lack. I miss that one every time. 3 and 0 make 3, and I lack. Oh, I got that one. 1 and 2 make 3. 1 and 0 make 1. Yeah.
So it makes it a little easier to keep from just adding.
If you do,
All your nines.
if you do, so if you establish this, so what'll happen is you go 0, 2, 4, 2, 4, 8, 4, 8, 6, 6, 8, 10, and then 12. It's in ascending order.
Very good.
But every time it goes there.
It goes back. It goes back and picks one up. Very good. Okay, so we got one more thing to do, and then I'm finished. All right? Oh, and let me tell you this, okay? Monday, starting Monday, the first 15 minutes of class, that is from the 15 mark to the 30 mark. You need to bring you something to read. It has to be physically something to read. It cannot be on a tablet, a device, okay? Electronic device, whatever you call those things. Does everybody understand? I don't care if it's a magazine. I don't care if it's a book. Whatever. But every day we're reading for 15 minutes. And at the 30, we're stopping because we got things to do. Okay? Every class is doing it. Why? Because they're pushing reading in the district. So they're pushing. They want to encourage reading. Y'all listen to me. Taking 15 minutes to read something, it's gonna be okay. I mean,
I like reading, but I was reading like fourth grade, and I remember like how silent you would read something, and that's like the zero really good. It was like called Pairs. Yeah, it's kind of done with
Wait, I have a question. You said starting Monday during 5th period, we're taking 15.
alright, so here we go. We're going to do one more problem and then I'm going to stop. Okay? So I need to start learning to cut us off at our 45 minutes. It's going to take away some of our playtime, but
Yeah, what are we going to do?
I know. We're not going to have any fun stories or anything. It's going to be work, work, work. Alright. So we are going to graph.
Is this like another thing?
Yep. Well, it's really something you already know, except there's one thing on it that you haven't ever heard of. It is so cool. And it's using stuff that you've already, maybe you learned, and hopefully you didn't forget. And let me just say this, too, about this little TSI test. People, I'm going to go look your scores up, and they better be good. You understand me?
I got really scared on that SAT practice. I think I was just drunk still.
The SAT practice.
Yeah,
The SAT? I'm talking about, oh, the paper? Oh, I'm talking about the TSI test. All right? So, now, technically, you guys don't have to be college ready, but I'm going to tell you this. If you're not college ready in math and you think that you're going to take a co-enrolled class next year, you're not. Okay? Because if you don't score high enough on that TSI test, they're not going to let you in that co-enrolled class. But they will let you take it again.
Did you ever see the news about the calculator status?
You're not allowed to bring the calculator in and use it, but they do have a click down, drop down calculator, whatever y'all call it. It's online. So it's a computer-based test. As soon as you finish it, you'll know what you score.
And the worst
Okay. So listen to what Luke said. Okay, I'm gonna. No, seniors are not. I don't think seniors are. I don't know that seniors are. I think they're going to call seniors in individually because it's only the ones that haven't ever had it. Okay, so here we go. Back on task, guys. Okay, so we're going to graph this thing right here. Now, first of all, let's talk about his zeros. What degree polynomial is this?
wait.
Very good. Does everybody understand why this is a fourth degree polynomial? Because here's an x squared times an x is an x to the third times another x is an x to the fourth. Okay? Now, let's talk about his zeros. What's this zero? And what else about that zero? It's a double root. Thank you, Tommy. It is a double root. Okay? Why? Because there's two of them, guys. There's an x plus 1 and an x plus 1. What's this root? Positive 1. What's this root? Okay. So I know it's going to touch here. I know 2, 3, 4, 5. It's going to touch here. And I know it's going to touch here. Is everybody okay?
I probably made my graph a bit big.
Now, listen, if it is an x to the fourth, what type of function is it, even or odd? Even. Tell me what that tells you about his end behavior. They're going to end the same way. The leading coefficient, is it positive or negative?
Positive.
Positive, because it's all ones, guys, okay? So that means he's going to start at the top and end at the top. All right, everybody okay so far? That's all stuff you should already know. So that means this thing's going to come down here like this. See? Starting from up here, he's going to come down and he's going to cross. Okay? I don't know how far he's going to go down, but he'll go down. We're going to find that on our calculator, and then we're going to put it in our T-chart. It will be a relative minimum. Okay? It'll be a minimum value. We're going to find it in our calc. Okay? Then he's going to come back up, and he's going to hit this. But wait. Listen to this. This is really cool. If you have a factor and it's raised to an even power, this thing right here, they call it a tangent. It becomes a tangent at that point. Here's what I say. I say it bumps that point. So he's going to bump this point and come back down again. Okay? Why is he bumping at 1, at negative 1? Because it's raised to an even power. Okay? Y'all, if this were raised to an even power, he would bump at -5. He wouldn't cross it, he would bump it. Now, is he touching there? Yes, because that's an x-intercept. You see what I'm saying? Okay, so even powers, when those factors are raised to even powers, it bumps it and goes back in the direction that it came for. When it's an odd power, like a 1 or a 3 or a 5, then it crosses it. So he goes down. Do I know how low he goes? No, but I do know he turns around and comes back up, and what? Goes through this and back up to the top. I'm going to find this minimum on my calculator, put it in my T-chart, and that's going to be my graph. Okay? Is that hard? That's not hard, is it? Okay. You already did it? Now, can I put that in my calculator just like this, or do I need to multiply that all out? Just like this, people. He's like, oh, give it to me, whatever. I can take it. All right, you can do it like that. It's not a big deal. All right, anybody got a question? I'm not going to do this right now. Well, y'all want to do it? We don't really have time to do anything else. We might as well. Okay, so let's take our little calculator.
What?
Go to y equals. I hope I didn't make a crazy one, because I did make it up. It's very dangerous making up problems, but it should be a W. All right, go to y equals, clear out anything, and let's see, what did we have? X plus 1, and then we squared it, and then X minus 1, and X plus 5.
-45.
Oh, I made a crazy one, and I'm shocked.
I'm really big enough.
Okay, so I'm going to be able to find this one pretty easy, but this one I'm going to have to go down here. Okay, so I'm going to go second and calculate. A minimum is number 3. Okay, there's my spider. Oh my word, he's already on the left bound. Thank you, Mr. Spider. So I press enter. Now he wants a right bound. There's the right bound. I'm writing that in my T-chart, guys. -0.39. Oh, sorry. +0.39. And -6.35. Okay? Write that in your T-chart. Now, to find this other one, what do I have to do? He won't find it off my graph, will he?
Yeah,
He will? Oh, then I'm home free. Second and calculate. I didn't think you would do that. A minimum. See, you're never too old to learn. I'm going to the left.
You have to go like a long way down.
Oh.
It's like -40.
What? Look, I'm way past it, goose.
Yeah, you're good.
I kept going the
You
last
just gotta do
time,
left.
started
You
over.
just gotta do left, right, and right bound.
Okay, so there's left bound. Let's go right bound. I need to be, oh, I'm there, because all I need to be is past that -5. -3.89 and -45.33. Obviously, I just let you make a little dot on your paper and write that beside it, okay? So, anybody got a question? Graphing should be pretty easy. All right, ta-da!